Hello, beautiful people. You're welcome to another interesting lesson on Maths with Ella. We are still looking at differentiation, and today we are going to see how we can differentiate implicitly or how we can differentiate implicit functions. So far, we've been dealing with explicit functions, that is, functions that can be written in the form y equal to f of x. That is, you can completely isolate y and then write all the other terms, the x terms on the right hand side. But in case we have a function as x y squared plus 2x plus 4y cubed, this function right here is an implicit function, and in order to differentiate this function or find the first derivative of y with respect to x, then we are going to proceed implicitly because this is an implicit function. Now let us use some examples and see how we can carry out implicit differentiation. Please, it is worth noting here that we're just going to apply all the various techniques of differentiation we've learned so far. So if you're not yet versed with the various techniques of differentiation, that is the power rule, the chain rule, the product rule, the quotient rule, please do well to check our previous videos so that you'll be able to follow this other lesson smoothly, because we are going to be applying all those techniques here. Now, examples. We have two examples here, all of which are GCE questions. The first example is a GCE 2019 question 6C, and the second example is a GCE 2014 question. So, the first example, find the x if x squared plus y squared equals to 16x. And the second example, given that xy squared plus cos 2y equals 7x, find dy by dx. So let us proceed and illustrate how we can carry out implicit differentiation. So the first example, x squared plus y squared equals 16x. We are looking for dy by dx. As I mentioned earlier, we're just going to be applying all the other techniques of differentiation that we've learned so far. That is the power rule, the chain rule, the product rule, the quotient rule, because of course implicit functions sometimes come as a product of two different functions, quotients, and so on. So all of that is going to come in handy here. So we're differentiating with respect to x. So x squared, differentiate x with respect to x, we're just going to have 2x. Here we're applying the power rule, that is, you bring down the 2 and then you subtract 1 from the power, gives us 2x. And then here, in order to differentiate y squared with respect to x, here we are applying the chain rule. We differentiate y normally, so we are going to have 2y. Then we attach dy by dx. This is as a result of the chain rule. That is, you differentiate y normally, you're going to have 2y. Then attach dy by dx to that term, equal to differentiating 16x with respect to x, we're just going to have 16. So we are looking for dy by dx, we need to isolate dy by dx. So everything that doesn't have dy by dx moves to the right hand side, giving us 2y dy by dx equal to 16 minus 2x, and then dividing both sides by 2y, we are going to obtain dy by dx being equal to 16 minus 2x, all of this on 2y. And that gives us what we were expected of the derivative of the function x squared plus y squared equals 16x. This is an implicit function, and differentiating implicitly or apply implicit differentiation, this is the answer that we obtain. Now let's look at the second example, which again is still a GCE question. GCE 2014 question 5b. Application of implicit differentiation. So the next one, the second example, we have xy squared plus cos 2y is equal to 7x. Okay. Now the first term here is a product, so we are going to be applying product rule, and because we have the y term here, the y, and we are differentiating with respect to x, we are going to apply chain rule, and that will mean we'll have dy by dx attached to that term whenever we're differentiating y. So this is the product. We apply the product rule. That is, you hold x and you differentiate y. Holding x, we hold x constant, we differentiate y squared. We are going to have 2y dy by dx. Because we are differentiating with respect to x, so each time you differentiate y, you have to add dy by dx. Now, plus, you hold y squared constant and you differentiate x. Differentiating x with respect to x, we have 1. So we are done with this first term. This is application of the product rule. Now, we are on this second term, cos 2y. Okay, so differentiating cos 2y, you differentiate 2y, you're going to have 2. Differentiate cos, you're going to have negative sign, then you write back the 2y, and again we attach dy by dx because this is a y term and we are differentiating with respect to x, and that is going to give us differentiating 7x with respect to x, we just have 7. So let us rearrange it and write it out nicely. We're going to have 2xy dy by dx plus y squared minus, this is 2 sine 2y dy by dx equal 7. So from here to here, I'm just multiplying to make it look better. So this is 2xy dy by dx plus y squared times 1 gives us y squared. So 2 times negative sine 2y gives us negative 2 sine 2y, then dy by dx equal to 7. So this equation is exactly the same thing here, but rearranged and written out neatly. Now we are looking for dy by dx. So we are going to group all the terms that have dy by dx and factor it out, and every other thing that doesn't have dy by dx, we move it to the right hand side. So doing that, we have 2xy dy by dx minus 2 sine 2y dy by dx is equal to 7 minus y squared. This y squared moves to the right hand side because it's a positive y squared. When it crosses the equal sign, it becomes negative y squared. Now the next thing is to factor out dy by dx because that's what we are interested in, and that's what we want to make the subject of this formula here. So factoring out dy by dx, we're going to have dy by dx into, so when we remove dy by dx from this term, you are left with 2xy minus 2 sine 2y is equal to 7 minus y squared. And lastly, in order to obtain dy by dx, we simply divide both sides by this factor here. That is, divide both sides by 2xy minus 2 sine 2y. We are going to be left with dy by dx being equal to, so 7 minus y squared, all of that divided by 2xy minus 2 sine 2y, and that gives us the first derivative with respect to x of this our implicit function that was given in our second example. Thank you so much for watching. I hope you learned, I hope you understood. If you have any questions, any doubts, or any worries, please do not hesitate to reach out to us, and we will reach out to you as soon as we can. Until I come your way again, remain blessed.